Myself, Dr. A.C. Nanan, Associate Professor, Department of Chemistry, Art, Commerce and Science College, Sony. Today, we start from TYBC Chemistry, paper number 8, Environmental Chemistry. So, today we study chapter number 3, Analytical Techniques in Water Analysis. So, nowadays, water is a main issue for the pollution. Water can be used for various purposes for the human being as well as the all living and non-living things in the world. So to study the water, so the quality of water must be purified and that parameters must be studied. Here the parameters of water quality characterizations are recorded in the following table. The tolerated limits for drinking water are laid down by United States Public Health USPS standard and the Indian Standard Institute SI systems are registered for the comparison. So these tables shows the parameters for the water. So table number 3.1, it shows the parameters of water quality standards for domestic water supply and its characterization. So parameters and the parameters which are given by the USPS standard and the ISI standard. Color, odor, taste. Water is colorless, odorless and tasteless according to USPS standard. Inorganic chemicals, ISI standard 6 to 9, pH 6.0 to 8.5, specific conductance 300 millimoles per centimeter, dissolved oxygen DO 4 to 6 ppm, total dissolved solids 500 ppm, suspended solids 5 ppm, chlorides 250 ppm and 600 ppm, sulfide 250 ppm, 1000 ppm, cyanide 0.0 ppm, 0.01 ppm, nitrate and nitrite less than 10 ppm, chloride 1.5 ppm, 3 ppm, phosphate 0.1 ppm, sulfide 0.1 milligram per liter, ammonia 0.5, boron 1 ppm, calcium 100 ppm, magnesium 30 ppm, arsenic 0.0 ppm, 0.2 ppm, barium 1 ppm, cadmium 0.01 ppm, chromium 0.0 ppm, 0.0 ppm, copper 1 ppm, iron filtrable less than 0.3 ppm, lead less than 0.0 ppm and ISI 0.01 ppm, manganese filtrable manganese less than 0.0 ppm, mercury 0.001 ppm, selenium 0.01 ppm, 0.05 ppm, silver 0.0 ppm, uranium 5 ppm, zinc 5.5 ppm, COD 4 ppm, carbon CSCl3 extract CCE 0.15 ppm, methylene blue active substance 0.5 ppm, phenols 0.001 ppm, ISI 0.005 ppm, pesticides 0.005 ppm, polys polycyclic aromatic hydrocarbons 0.2 ppb, surfactants 200 ppm, radioactivity that percentage is not given according to USPS system and ISI system. Gross beta 1000 picocuries per liter, iridium 226 radioactive elements, 3 Pc per liter, strontium 90 radioactive element, 10 Pc per liter and less than 5000 Pc per liter. Bacteriological parameters. Californium says 100 ml, that is 100 ppm. Total bacterial count 100 ml, that is 1 into 10 raised to 6 ppm. So Pc means picocuries. From the above table, it is clear that the values given by ISI system are much higher than those by USPH and that two or no good reasons. Then types of water. There are two types of water. One is a surface water and second is a groundwater. So number one is a surface water. The permissible limit for the above permission parameters for surface waters are 3 to 5 times higher as compared to that of drinking water. The general requirements for water use for recreation, that means swimming, rowing, and navigation, etc. Anesthetic aquatic life, fish, wildlife, and irrigation can be discussed as follows. Recreation and aesthetic water. Surface water used for the recreation and aesthetic should free from number one, materials like oils, grease, phenols, etc., which give color, taste, and turbidity. Substances which may settle from unacceptable deposits, such as debris or clouds on the surface, such as oils and foams or froth. Toxic substances, including these which are physiologically harmful to the human being, fish, or other aquatic plants and animals, along with radioactive nuclides. Substances which are likely to result in promoting the growth of undesirable aquatic life, fish life, and wildlife. In case, it is accepted that the surface water used for aquatic life, fish and wildlife should be free from number one, settleable matter which harm happens to growth of floats and biota, floating matter such as oil and grease as they form visible color, films on the surface, coast banks and bottoms of water courses, pollute aquatic biota and causes toxicity fish and man. The temperature of wastewater should not be 6 to 9 degrees centigrade. By mixing of hot water, the pH and dissolved oxygen should be within the USPH and ISI limits. Irrigation water. Salinity or total dissolved solids TDS is the very important parameters for the irrigation water. The irrigated water is made available to plants through a mechanism regulated by osmotic pressure within the plants. The permissibility limits of trace elements in ppm present in irrigation water are given in below table. So this table shows the permission of these elements in the irrigation water, elements and their limits in ppm. Aluminium 1 ppm, arsenic 1 ppm, beryllium 0.5 ppm, boron 75.75 ppm, cadmium 0.005 ppm, chromium 5 ppm, cobalt 0.2 ppm, copper 0.2 ppm, lead 5 ppm, lithium 5 ppm, manganese 2 ppm, molybdenum 0.005 ppm, nickel 0.5 ppm, selenium 0.05 ppm, vanadium 10 ppm, and zinc 5 ppm. These are the permissible limits of elements in the irrigated water. Then second type as a groundwater. So the groundwater, especially well and tube well water, have higher dissolved minerals as compared to the surface water. And this is because it is in close contact with rocks and minerals as well as solids, along with carbon dioxide bearing water in the ground for a longer period, which allows dissolution of minerals in it. Sampling of water. The collection of meaningful data demands that correct sampling and storage procedure must be used, and this procedure may be quite different for different species in water. So, separate sample must be collected for chemical and biological analysis. This is because the sampling and preservation techniques differ significantly as per the purpose of analysis. Therefore, usually the shorter the time interval between the collection and analysis, the more accurate will be the data or more accurate will be the result of water analysis. Some analysis must be carried out in the field within the minutes after the sample collection. For example, temperature, pH, dissolved gases like oxygen, carbon dioxide, and H2S, chlorine should be done on the field. So some factors are very important for sample collection or the in programming of sample for their study of parameters. So the number one, frequently sample must be collection. Next one, total number of samples. Next, size of each samples, sites of sample collection, method of sample collection, data to be collected with each sample, and transportation and care of sample prior to analysis. So these are the main factors which are very important for the analysis of water sample. Water samples can be divided into two types. Number one, grab sample. Grab sample means these are the taken at a single time that took from different depth at a single places. Hence, they are very well defined with respect to time and location. Second, composite or mixed sample. These are collected over an extended time and may include different location as well. Samples may be composed of 4, 8 or 24 hours of time period. It depends on purpose of analysis. Factors relevant sampling of the program. Separate sample must be collected for chemical and biological analysis. So the sampling and preservation technique are quite different. Final, Finally, it is essential to keep accurate records of the location, time, and condition of sample collection. So this is the table for water sample collection or water sample preservation, means parameters, minimum sample size in ml, then container and preservation. So these are the precautions which are taken for the collection of sample for the analysis of parameters of water. Number one, for measurement of pH, minimum sample is 100 ml, container is polythene bag, preservation measure within 0 to 4 hours. Dissolved oxygen 100 ml, polythene bag, there is no time for the preservation. COD, chemical oxygen demand, minimum sample is 500 ml, polythene container is the polythene, add H2SO4 to maintain the pH 2 and then it place in the refrigerator. Nitrogen and ammonia, maximum sample is 500 ml in polythene bag, then analyze as soon as possible. Add 0.8 ml concentrated H2SO4 in per liter for the preservation. Next parameter, nitrite and nitrate. Total collection of sample is 500 ml, collected in polythene bag. Add 40 ml HgCl2 in per liter and then place in refrigerator. Cyanide 500 ml sample in polythene bag. Add sodium hydroxide to maintain the pH 12 and 12 to 15. Then 15 ml, 0.15 ml, 2% ascorbic acid and then place in a refrigerator. Sulfide sample is 500 ml, container is a polythene bag. Add 1 ml to normal zinc acetate and 2 ml 1 molar sodium hydroxide. Stir and place in refrigerator. Phosphate 500 ml sample, polythene bag or glass bottle. Add 400 ml HgCl2 in per liter and place in refrigerator. Next parameter, tannin and lignin. Sample is 500 ml, container is polythene bag or the glass bottle. Analyze as soon as possible. Next parameters are chromium, arsenic, lead, zinc and mercury. These are the heavy toxic metals. They are analyzed by taking the sample 500 ml in polythene bottle or glass bottle. Add 5 ml concentrated nitric acid in per liter and place in a refrigerator. E. coli bacteria or total bacteria and the acetomycetes. Sample is 100 ml. Container as a glass bottle. Sterilize bottle in autoclave for 15 minutes. Then collect the sample in sterilized bottle and refrigerate immediately. Next parameters, microplankton or algae and other biological organisms. Maximum sample is 500 ml. Container as a glass bottle. In that glass bottle or container, add 5 ml formalin per 100 ml sample and refrigerate immediately. So these are the parameters and sample collection for the analysis of various parameters of the water sample. From this table, we say that the glass bottle or polythene bottles used for sample collection should be thoroughly cleaned by rinsing with 8 molar HNO3 followed by repeating washing with deionized water. One precaution must be taken for the sample analysis or the sample collection. For bacteriological examination, the bottle should be sterilized. Thank you.